to a brief introduction to RAISE's Unit 5. Unit 5 is chunked into 3 sections that focus on the following skills. First, simplifying numeric and algebraic expressions using the laws of exponents, and simplifying numerical radical expressions involving square roots. Next, interpreting the meaning of the values of a and b in the exponential functions of the form f of x is equal to a times b to the x power. This is done in real-world problems, and then students write exponential functions to describe problems that arise from these mathematical and real-world situations, including growth and decay. Third, graphing exponential functions that model growth and decay and identify key features. And then finally, comparing linear and exponential functions. Now, this is not a skill that you will see in a separate section of its own, because it's embedded within each of the other 3 sections. So let's first check if the students are ready. Remember, the overview and readiness lesson pre-assesses students' understanding of 3 prerequisite skills, and it provides them with a mini-lesson for each skill that they have not yet mastered. Once that's complete, we can dive into our lessons. Section A can be viewed as containing 2 parts. The unit opens with a refresher on the laws of exponents, and then it expands into simplifying radicals and rational exponents. Once these skills are reviewed and practiced, students are introduced to exponential relationships. They learn that exponential relationships are characterized by a constant quotient over equal intervals, and then they compare it to linear relationships, which are characterized by a constant difference over equal intervals. They encounter contexts that change exponentially, and they're presented to these contexts verbally, graphically, and with tables. Then they construct equations and they use them to model situations and solve problems. But I want you to note, in this section, students investigate these exponential relationships without using function notation and language, so that they can really focus on gaining an appreciation for the critical properties and characteristics of exponential relationships. This section also includes lesson components that review student understanding of scientific notation, primarily in the last part of Lesson 5.6. While this content is aligned with Grade 8 mathematics, it could be considered optional, but students will begin to use this information in their high school science classes, so it may be of value for you to include. So, in summary, Section A really focuses on using the laws of exponents to develop student understanding of patterns of growth, and then comparing that to linear functions where the change was dictated by common differences. If students demonstrate a strong understanding of the laws of exponents, then the lessons in this section may be compressed to shorten the number of days needed for instruction. So let's check out Section B now. In this section, students focus their attention on how to represent patterns of growth and decay as functions. The 6 lessons in Section B form the core of student understanding about exponential functions. Here, students begin to employ the notation and terminology of functions. For example, dependent and independent variables. They study graphs of exponential functions in terms of both real-world and abstract contexts. And it's here where they begin observing the effect of different values of a and b and how they impact the graph represented by f of x is equal to a times b to the x power. So to summarize Section B, if you're looking for which lessons in this unit to expand, this is the section in which I would add extra time. These lessons where students identify key characteristics and link them to what they mean in terms of the context are crucial. Let's break it down a little bit. Lesson 8 focuses on writing situations using function notation. Then Lesson 9 starts comparing the function notation to the graphs and the relationships between the equations and the characteristics of the graphs. Lesson 10 applies the concept of rate of change to exponential functions, and it uses linear functions as the comparison. Then in Lesson 11, we allow students to really investigate. They check out the height of a bouncing ball and how it might be modeled using exponential functions. And finally, in Lessons 12 and 13, students explore the effect that changing A and B have on the graphs of exponential functions and on the other features of the graphs. Of special note in this section are videos that are available to students. And I'm going to pause here because I would like to suggest pulling out some specific pieces for students to watch and discuss. It's what I would do in class. So, for instance, in Lesson 5.8.3, there's a really nice explanation for why the growth factor or depreciation factor is not the 1/3 number that students tend to pull out of the problem's wording. In addition, in Lesson 5.10.2, the video provides a great visual comparison of the rate of change for something that is linear versus something that is exponential for given periods of time. And then in Lesson 5.11.2, if your students are still struggling to understand or see how exponential functions are different from linear functions, the explanation of the table provides specific numeric values as illustration of the inconsistency over time. Now, finally, in Section C, students learn that the output of an increasing exponential function is eventually greater than the output of an increasing linear function for the same input. Lessons 14 and 15 in Section C really push students to deeply think about the graphs and characteristics of exponential and linear functions, and to make predictions. Lesson 14 addresses this in a more concrete way, and it leans on the use of graphs to scaffold student learning, while Lesson 15 takes the comparisons and predictions into more of an abstract level. Just a quick note that additional time may be needed for Lesson 14. Now, I want to pause for a second, because all of this that we do, we know is going to be assessed on STAR. So I want to point out that when assessed on STAR, most of the questions come from content that is taught in sections B and C. So those may need a little more time. So let's talk about pacing. If the entire unit is used as is, Unit 5 should take a total of 20 days, including an allotment of class time for quizzes, the STAR review, and both projects. But if you need to add time or compact time, you'll have to make the adjustment. So wrapping up Unit 5, you might be wondering, what's up next? In preparation for the last units on quadratics, Unit 6 has students working with polynomials. This includes performing all of the operations with polynomials and one of the most challenging topics for our students, factoring.